Hello students, in the previous lectures I told you how to differentiate a function. You have read the first principle of differentiation in plus 2 and we have generalized that definition to some other form for of function of one variable. Now, in the last chapter, we'll generalize this definition of differentiation to the function of more than one variable. In the last chapter of this book, this definition was 14. Now, in this lecture, we will discuss how to find the differential of higher orders and how to find the differential of up to nth orders of function if function is if the derivative of up to nth order of any function exists. How to find that and what are their notations? Uh, Let us know that y is equal to we are given a function. We, if we differentiate this with 2x, you know the ordinary differentiation. We write ddx of y, and this is the first order derivative or first order differential coefficients. This is the if if now this is a new function, you get a function, this function of x, the new function. If this function is again differentiable, we again differentiate with this 2x, you get the second order derivative d2 d2 dx2 of y is the second order differential coefficient. Now again we'll get a function. If this function is the resultant function is differentiable, we again differentiate that with this 2x and then it is the d3 of y dx3 and so on. We can find the differential up to nth order of this function y is equal to fx if that exists, and their notations are the exact notation and derivative dn y dx. So basically, and this is the differentiation which we did for we differentiate y is to x first, then this y is to x, differentiate y is to x, then with this to x again, and this process of finding the second order third order is called successive differentiation of y is to x. So then one by one we find a differential. One to x we differentiate that and then again the new function is a function of x, again we differentiate that, the resultant function again a function of x, we differentiate that, and so on up to the, this is called the nth order nth derivative of y is to x, and their notations are dy dx, second derivative y is to x, third derivative y is to x, and nth derivative y is to x. So symbolically, in order to save time, we write them y1, y2, y3, yn, or y dash, y dash, y double dash, y third dash, and y nth dash, or dy, d2y, d3y, dny, or f dash, f double dash, f triple dash, and f dash. The notation for the successive differential of y is equal to fx. Right? Now let's solve problem. While solving problem, we must follow some certain technique to find the nth order derivative. We will generalize while solving the question in place of cancelling out the factor. We generalize in place of cancel out the conflict. Now let's discuss problems. Find the fourth order derivative of this function, right? Log of root of 3x plus 4. So let y is equal to this. Now this function of x. Now we know log formula. Log of x. 3x plus 4. Now differentiate this to x. So first order derivative of x is equal to is a constant. Differential of this will be log of x is equal by x. And dx of x will be is equal to j2. So we got the first order derivative. So we write it. Yeah, 1 by 3, 2 by 3, 6 by 3, 1 by 3, 6 we write in standard form because we can't differentiate it in the denominators. We write in the form of dx of x over minus 1. We use the formula dx of x over n. Everywhere, if we got the linear factor in the denominator, we take the numerator and then differentiate. Then use formula dx of x over n. Now again differentiate this with 2x. So your differential coefficient will be under the constant outside dx of this is equal to my n plus 1 minus 1 dx of x. Again is equal to 9 3 square. We can add minus 3 square. Second derivative y is to x is equal to minus 3 is 9 by 2 minus 1 into minus 1 into 3 by 3 3x plus 4 into minus 2. Again differentiate to x is equal to this is minus 2 minus use the formula the constant outside use the formula this and this is equal to minus 2 cancel out this is equal to minus of plus or we can generalize that some other way minus 2 it's minus 3 so it's equal to minus 3 and fourth order derivative of this equal to minus of this minus of this 7 same formula we have just used the formula dx of x or n or log of x dx of log of x and dx of x is to solve this up to fourth order problem. So in this case we have not generalized it. Now in the next problem I tell you how to generalize this, how to generalize for finding a successive differential coefficient of a now if fx is bigger than fx, then show that uh, fifth derivative of 0 is equal to 16 equal to 16. So given is fx is taken x, differential is to x, secant square x, secant is 1 plus tan square x, equal to tangent x. Again differentiate this is to x, f delta x is equal to constant 0 is equal to 2 tangent x, secant square x, again secant tangent square x, secant square x is 1 plus tan square x, converted to tangent x. So this is this, so we can get to this is fx, this is fx. So 2 again differentiate this with x, so 100 is equal to fx is equal to 2 so just 6 into nx minus 1 into fx. Again differentiate this with x, this is second derivative of fx. Again the product here, first function substitution, 6 is outside, nx minus 1 and 2 fx f dash x into f dash x and this is fx whole square f dash x and simplified it and again differentiating this with 2 x we got that this got the derivative. So what is this f dash x this is equal to f dash x differentiating this with x 2f triple dash x 12 is common product is here 6 is common product is here product is here and after simplification we got this result and now we are asked to find derivative fifth derivative of tangent x at 0 into 16. Now after finding the fifth order derivative of this we substitute the values in the f at 0x equal to tan 0 equal to 0. So see here, f dash at 0x is equal to tan 0 equal to 0, so 1. F double dash at 0 is equal to 0 at 0, and this is 0, 0, 0. F third derivative 0 is equal to f first derivative 1 and 0 is equal to 2. F fourth derivative of 0 is 0, and similarly substituting their values, substituting in values here, you get x equals value of f was f dash, f double dash, f triple dash, f 4 times up to third derivative. Substituting here, you got this way. So now, if you are asked to find derivative at fourth order or fifth order derivative at any point, first you have to find the that order derivative of the given function, fourth or fifth or whatever order of the function derivative you are asked. First find derivative, then then make substitution from the first equation for second, third, from successive order, first order, second order, from function, first order, second order, so third order, fourth order, and successively till the last of the derivative. This is the process how to find the value of function. Now let's discuss an example. If y is equal to e is for x sin x, then prove that second derivative y to x is equal to 2 e for x pound x. Now again, yes, she's asking us to find the second derivative. So this is first question given y is equal to e to x sin x, differentiate with to x, product to first and second function, differentiate product in derivative for u into v. So this is equal to first function is derivative, second is equal to sine of x cos x plus dx ex is equal to cos x is equal to common is for x. Now again find differential of this second equation is to x. So differential is to x is equal to this. Therefore again differentiating this, we got this first function, this is second function. First function it is differential second plus this is first second like this. Now e to x is again common, cos x is common, so this will be equal to dx of cos x equal to sin cancel, this is equal to your cos x sin x cancel out. This will be your cos x proof, sin x and cancel is equal to cos x. Now again, if y is equal to sine of m sin inverse of x, prove that 1 minus x square of y second derivative of y minus x by 1 plus m square is equal to 0. Now again, we are asked to find the first order and second order. Y first order, second order. So take this function of x, y function of x, first equation, differentiate with to x, chain rule, differential of sin x is equal to cos of x, dx of m sin inverse x is equal to, m is common, the sin inverse x is equal to 1 upon root of minus x square. Now cross multiplying is equal to root will be root of 1 minus sin is equal to squaring both sides and converting them into cos x equal to 1 minus sin square x. This will be equal to y square. Now we remove the derivative function from here and we got an equation square 1 minus x square by m square is equal to m square 1 minus y square. Now again differentiate both sides to x. In differentiate product here first function second function with this and differentiate this. Every problem is being done in the same way. Now first function as it is, differentiate of second function by y1 square is equal to n y1 n minus 1 into dx of y1 y2 is equal to first differential first function minus 2x, second function as it is is equal to m constant, m square constant is equal to derivative for 0 is minus 2y. Now at this step, you'll get this step in every problem where common factor will be there. You have to cancel out the common factor in this step. Both this 2y will be common factor. Whatever common factor you get after differentiation, you have to cancel that out for proceeding the. And now in this case, so 2y1 is a constant, so dividing both of 2y1, we got the equation which there is no common factor, and we got the legal answer. The next question is a parametric one. Okay. If y is equal to a into cos t plus t sin t, y is equal to a into sin t minus t cos t, find the second derivative to x at x equal to 5. Now again, this is a parametric form. How to find the, how to differentiate parametric function. So first we need to find the second derivative, find the first one. First derivative equal to differentiate x written as x is a function of y function t, y function t, derivative dt. So and second derivative will be equal to demonstration y is to x is equal to is to x into dt dx. Equal to dx dt dx. Now this will differentiate first and second is to x and y. X and y. So this is to x is equal to minus t a into constant minus dx of cos minus sin dx of t cos t, and the sign cancel out at. Similarly, because y is to x, which y is to t, we got at and t. Now differential of y is to x is equal to a t sin t, a t cos t is equal to tangent t. Now, in order to find second, now it's a function of t. Now this become y become function. Now this new function become function of t. So we will, in order to find the second derivative is to x, and then function of t. Y is function of x, x is function of t. So we say y second derivative is to x is equal to dt dx, we have separated out, and dx dt. So y is to t, so y is to x is to t, dt is function of t, to dt dx. That's substituting the value. Divided t is equal to 6 secant square t, and dt dx is equal to 1 cos t, dt dx is equal to dt dx reverse of this, equal a t cos t, equal a t cos t. Substituting the value in this formula, substituting the value and cancel them out, we got is equal to 1.80 cos 2t. Now its value at t is equal to 5, substitute t is equal to 4. Next is again this is a, if x is equal to sin theta and y is equal to sin and theta, prove that. Now they again parametric form. Prove that 1 minus x square sin dy is to x minus x sin dy is to x plus my. Now again parametric form, same process will be x into here, y is function theta, basically x is to theta, y is to theta, m cos m theta, this is the to sin cos theta. Now again same process, y is parametric form, y function x will be dy d theta, dx d theta, substituting value, simplifying them, we got y1 is equal to m under root of, so we cos sin m under root of 1 minus y square, 1 minus x square, cross multiply. After cross multiplication, now he has removed the theta from here. Now we got y1 is equal to either remove the theta, cross multiply, squaring again. So again we got the same result, differentiating both sides to x and cancel out the common factor. Income factor equal the required. This is a different way of solving that. We have now solved in first class from by this way. First order derivative, same process. Second, we in order to find second order derivative, we want to remove the resultant function. From the resultant function. We want to remove the parameter and convert it to single variable. Right? Convert it to single variable. Now, next problem is, if y root of x plus root of y is equal to a square, find the value of 725 squares at x. Okay, 725. This is a implicit function. Implicit function. So how to, do you know how to differentiate implicit functions also? This is differentiate equals to x. Y is the dependent variable, x is independent, y is the function of x. So differentiate this by x, it's half, and x minus 1, and x minus 1 into dy dx. Here will x with x into 1. Divided. Everywhere you apply this rule. Now, simplification after simplification, we got the one, we got the differential by square. Side. Now again differentiate this two squares. Now what's the proof? The whole square, numerator is differential numerator minus numerator is differential numerator. Computing the value. Now this is equal to x. How to find derivative? Half y minus 1, which is y square, y. Simplifying them. Sometimes substitute differential by value. You have to substitute in this steps. dy square. Substitutions, you have to substitute the value, and right hand side you have to remove the differential option, and then after simplification you get second derivative of square will be equal to. Now you are asked to find the value at some point, so replace x by whatever you have to find, put the value and the required series. Now when any type problem, find the value of ABC so that the function, this function is twice differentiable at x equal to 1. Twice differentiable. Now the function is twice differentiable. Let's understand the concept. We are given uh, three unknowns are given to us, and this function is given twice differentiable, and this function is polynomial third order and polynomial second order. For x less than or equal to 1, and for x greater than 1 is second order. Now let's discuss, and if it is twice differential, we'll find the second order. If x is given to us, then first order derivative says second order derivative. Given fx is twice differentiable at x equal to 1. Given that is x equal to 1. So this means f double dash at 1 exists. So if f double dash 1 exists, f double second derivative of f at 1 will exist if and only f first order derivative of f at 1 exists. Now the first order derivative of f at 1 will exist if f is continuous at x. And now you'll get three questions for this. For the second order derivative function at a point like this, the first order derivative at that point must exist and the function must be continuous at that point. Then and only then the second order derivative at any point of any function will exist. Right? Now let's start the problem. Second order derivative is second derivative of f at this, that is left derivative of f double f dash minus 1 into that. Left derivative this, left second order left derivative, second right derivative. First derivative left hand derivative first order at 1 is equal to right hand derivative of f at right derivative for first order at 1. For the left derivative, right derivative, and we got second equation. We got 1. So from this we got 3. got the equation of B. And first equation we got A equal to 3. Second condition we got A by putting A equal to 3, we got B equal to 0. And F is continuous at 1 means left and limit at limit 1 to negative is equal to F value at 1. Now take the function, take this function and substitute the value, choose the values in this, and we got an equation in ABC. A and B we got from the first simplification, third substitute the value of B and we got the value of C. Thank you very much.